Okay, so here we're going to we're gonna move on from the the way we solved a system of equations in the previous section, right, to just a more streamlined approach. Easier to do computations. You probably use a computer to help us with the computations, all right, when possible, right? And that's going to involve this idea of using a matrix, right? So first of all, let's start with just basic definitions, right? Matrix, right? So when we see a matrix, it's a collection of numbers. Here, let's see, 0, 7, 8, 6. All right, organized in rows and columns. All right, so here we call this, so notation says m by n. So m is referring to the rows, n is referring to the columns. So for above, the matrix A is a 3 by 4 matrix. All right. So A itself refers to the whole matrix itself. If we want to reference a particular value, right, we use the notation A. For example, 1, 1, right? That is referring to first column, first row. So that is 1. Let's see, A, 3, 2. All right, so 1, 1, first row, first column. So 3, 2, third row, second column. So that would be 7. All right, so that's how we would reference the elements of a matrix. All right, so this is a matrix, right? So matrix along with column vectors. Right now, a column vector is just a vector. Essentially, you can think of it as a m by 1 matrix, right? Where here this is, right, A1, B1, B2. Excuse me. Let's keep the streamline here. A1, A2, etc. A sub n. Right, so a vector that looks like this. Right. Now, a very special column vector is something called the zero column vector. Now, in general, while our matrix notation uses capital letters, for vectors, we tend to use this either boldface type or just a lowercase letter with an arrow up top. Right, the zero column vector is a special column vector, right, in that all of its elements are the constant 0. Okay, all right, now keep in mind here, right now, in terms of what we mean by equality here, that this 0 vector is not equal to 0, right? It's a vector, right? So let's start being kind of mindful of when we use like equalities, and it's important what is on either side of those equalities, right? They have to be first the same thing, right? And they have to be equivalent, and whatever that means, the term equivalent, equal for whatever object it is we're talking about, right? Now that'll show more when working with vector spaces, right? But for now, just keep that in mind, right? The 0 vector is an object, it's a vector, right? It is not 0, it's the 0 vector. 0 is the constant, right? It's a real number here, while the 0 vector is a vector. All right, so here now, how does this play into my general system of equations, right? All right, so here, A, 2, 1. Okay, so here M excuse me. Okay, so this is our general system of equations here, and we want to have a representation of this in terms of matrices and column vectors, right? So we start off by first the coefficient matrix. And what that is going to entail is all of the coefficients of our variables, right? So here, right? So the first row is going to be all of the coefficients of my first equation. So A11, A12, etc. A1n, A21, A22, A2n, etc. We got A M1, another way of A M N. Okay, so here we have an M by N matrix, where M, the rows, represents the number of equations, and N, the columns, represents the variables, right? We can think of each of these columns representing the coefficients of the first one, all of my x1 variable, all of my x2, all of my x3, etc., till I get to xn. This may or may not be square, right? As we've seen in the previous section, right, the systems of equations, right, we can have overdetermined in the sense there's more equations than variables, or underdetermined where we have less equations than we do have variables, right? That is okay, okay? All right, now that is our coefficient vector. Now the vector of constants, which we'll call B, is what we have at the right side of the equal sign. B1, B2, all the way to Bn. Right, and that is my vector of constants. Okay, and now we have a third part of this equation here, or about this setup here, is the solution vector. And that is defined by x, and that is x1, x2, all the way to xn. Okay, now here this could represent just the variables, right? Or it could actually represent a specific solution, right? Or a general solution, right? Just depending, right? In context in what we're doing, right? In general, it just can represent the variables or the actual values of a solution. Okay, all right. Okay then, so this brings us here. So we have the solution vector as to a matrix representation of a linear system. So we'll use this notation here. So when we see, so a linear system with A being the coefficient matrix and then B being the the vector of constants. All right, so that's the notation that we'll do to reference our linear system. Okay, now in general, when we get into matrix multiplication and all that, we could see here, we can write it as an equation here that is like this, right? But that'll come later. For now, we'll just reference it as this object, this LS, A being the coefficient vector and B being the vector of constants. So going over an example here, let's say we had the system represented by not squared. And then 3x1 plus x2 x4 minus x5 equals to 0. And then minus 2x1 plus 7x2 minus x3 is 5x3 plus 2x4 plus 2x5 equals to negative 3. All right, so in this example, what I want is I just want to write it, the matrix of coefficients, and then write the vector of constants, right? So A, right, so it's going to be a matrix where we have 3 rows, right, corresponding to the number of equations, and 5 columns corresponding to the number of variables, right? So my first column will be 2, 3, negative 2. Second column will be 4, 4, 1, 7. And then my third column, negative 3. Now the second one doesn't have an x3, so we still need a placeholder there. So we put 0, negative 5, and then 5, 1, 2, and then 1, negative 5, excuse me, 1, negative 1, 2. All right, so that is my matrix of coefficients. All right, now the vector of constants is just going to be here, what they're each equal to, 9, 0, negative 3. All right. All right, so that is my vector of constants, right? So both of these together represent the linear system A, B in terms of my matrix and my vector of constants. Okay, now just keep in mind here that, right, there's a lot of vocabulary here, right? So go through, make sure that you are comfortable using that vocabulary, right? Part of this is also not just being able to do the math, but be able to speak in the proper, using the proper vocabulary, right? So it's going to be important that we know these definitions, a linear system, a matrix of coefficients, column vector, the 0 vector, rows versus columns, etc. Okay?